Today we're going to attack some inequality problems in terms of solving general inequalities, absolute value inequalities, and then we'll finish the day with applications of rational functions. So if I look at the following solutions and ask for graphical and interval notation solutions, let's chat about those. Inequality solution is x is less than 4. We know from, I'm not even sure what grade it is, Algebra 1 definitely. Open circle, arrow going to the left, and a 4 beneath. Now, to say this in interval notation, this may be new for some of you. This is what we're going to use to describe solutions. We won't be graphing them anymore. We'll be describing our solutions with interval notation. What we do is we say, okay, this value, the lowest it goes, is infinity of the negative type. And that's unbounded. We can't say, well, there's an end to it. So if something is unbounded, we give it a parentheses. Throw in negative infinity right there. All right. And then we look at the highest number in the set, which is 4, and say, is that bounded or unbounded? Or another way to say that is it's included or not included. All right, this is not included, so that gets a parentheses as well. Let's show you how that differs from something being included. If I have x is greater than 7, we would close circle it, arrow going to the right, put a 7 right here. We look at our smallest number, that's always going to go first in our interval notation, but we notice that this 7 is actually included, so that gets a bracket. We put a 7, and that goes all the way out to positive infinity. But positive infinity, you can't include that because it just keeps going forever. It's not bounded. So we parentheses that. So here we have a double inequality, if you will, and this is kind of like an and or a conjunction problem that we got from Algebra 1. And it says, well, I have an included -2, so that's a closed circle, going to a positive 8 that's not included, open circle, connect the dots. In our interval notation, we have a bounded value or an included value of -2. That's our smallest. Going to 8, which is our biggest, but it's not included. Finally, this is called a compound expression as well. All right. But this is an or statement. So if we start at 5, but it's not included, going to the left, and then 9 not included going to the right, that's what the solution would look like in a graphical sense. In an interval notation, our least number on this left side is negative infinity, and it goes all the way up to 5, neither of which is included, so we parentheses. Then we go from 9 to infinity, neither of which is included. To join these together and say, hey, look at both of these as part of your solution, we say that's a union of those two sets for my answer. You don't have to write the union in, you just put an N there, okay? And in set notation is actually an upside down N, that's the intersection, but we're not going to use that. So now you know about interval notation. Now we're going to solve some inequalities. If you remember, it's just like solving an equality, except when you get to a certain step. So I'm going to distribute that through. We get a negative 9x minus 15 minus 1 less than x minus 18. Get all my x's to one side. Now I'm a fan of putting all my positive x's on one side. So I'll bring that 9 over, get me a 10x. This is negative 16, add negative 18 to that. 16, 18, 34, right? Of the negative type. Or actually, I lied. That's actually going to be 16, and then I'm going to add 18. So that's going to be a positive 2. All right? Thus, we get x is greater than 1/5. Now, a lot of the times we'll take a look and say, okay, well, what's that going to look like? That's going to be something like this. All right? But I want the answer in interval notation. So this is just to help you now. So now my smallest number is 1/5. Goes all the way out to infinity. Neither one's going to be included. That's my interval notation solution. Now, notice we have two inequalities in one set. So in order to do this problem, this again is a compound inequality. we're going to take and split this apart. And this says x minus 4 is less than 5x plus 7, which is less than 2x plus 20. So I split it apart like this. I say x minus 4 less than 5x plus 7 and 5x minus 7, or plus 7, sorry, is less than or equal to 2x plus 20. We're doing two problems. So again, this is 4x, this is negative 11, x is greater than negative 11 over 4, and let's go 3x less than or equal to 13. So x less than or equal to 13 over 3. So if I look at that and I say, okay, well, x is greater than negative 11 over 4, and x is less than 13 over 3, then the only way that's true is if it's in between those two. All right? So therefore, I'm just going to start with my smallest, negative 11 over 4. That 13 over 3 is filled in to 13 over 3. 13 over 3 is included. 11 over 4 is not. Interval notation. So this is a little different spin on this. It basically just has a bunch of different solutions, but here's what I'm going to do. I'm going to graph x is greater than 5, or x is less than negative 2. Or basically means everything. So the answer to this is this graph, if you will. Then we're going to and this guy with it. And means intersection. So I'm going to, in the same kind of area as this guy, pop a 0 in here and a 6 in here. Fill both of them in and connect the dots because those are the values between those. Now, because the and tells us to intersect these two graphs, I'm just going to see where they would overlap. And they overlap basically from the 5 to the 6. Because there's nothing from 0 to 5. There's no overlap. So I notice 5's not included, but 6 is. And that would be the interval notation for the solution of this equation. Now we jump to absolute value inequalities. We talked about before that absolute value inequalities talked about if we want to work with absolute values, we got to pull the x out. And to pull the x out, we found that the value inside is either a positive or a negative of that x. And that's going to be less than 10. Now, if I were to break that apart and say x is less than 10 and negative x is less than 10, we remember from doing inequalities way back in 7th or 8th grade that when we isolate x and we multiply by a negative, or divide for that matter, then we flip the inequality sign. So now I take a look at these two graphs. Here's a 10 that's not included. Goes this way. And here's a negative 10 that's not included. Let's do this. And it goes this way. Now, these guys end up overlapping, okay? And when they overlap, that's kind of like an intersection. So the solution of this is going to be basically here, all right, like so. And you can tell that's the case because look at, if I picked a number outside, like using this arrow, if I said, well, both of these graphs could be the answer, I could pick a number like 20 and plug it in here. Well, the absolute value of 20 is not less than 10, so that doesn't work. I could pick negative 11. Absolute value of negative 11 doesn't work. The only values that are going to work are the numbers that are in between negative 10 and 10. Now, in that case, my solution would be negative 10 to 10 in interval notation, neither including. Little key, absolute value isolated, less than, okay, it's an and problem. Anytime you have an absolute value less than, it's going to be an and problem. Looks something like this. Now, if I look at, hey, let's look at the graphs when the absolute value is greater than or equal to 5, plus or minus x greater than or equal to 5. So I have x greater than or equal to 5, x of the negative type, whoops, is greater than or equal to 5. Multiply by the multiplicative inverse, flip the inequality, like so. Here's negative 5 going to the left, and positive 5 going to the right. Notice this is a separated, looks more like an OR problem, and it is an OR problem. And any of these values in this graph are going to satisfy that problem. So this looks like an OR problem, which means when I state the answer in interval notation, I've got negative infinity to negative 5 with a bracket. I've got 5 to infinity with a bracket. And I'm going to have to say, hey, look at both of these, so I'm going to union those two. And once again, the absolute value is greater than something, greater. All right, so any absolute value that's greater than a number is an OR style problem. So you know you're going to have a union. All right, so now this is a general problem again. As I explained before in the class, that's just some term, like a happy face. And I know that to pull this out of the absolute value sign, I can't work with anything, but I got to pull it out. So I say plus and minus 3 minus 4x is less than 8. I know this is going to be an and problem because it's less than, all right? And I know and problems could look something like this. For instance, I could put plus or minus over here by multiplying, right? If I wanted to, but I'm not going to. I'm just going to basically say it's an and problem. So I know that negative 3 minus 4x is less than 8. Oh, I lied. That's a positive 3 minus 4x is less than 8. And a negative 3 plus 4x is less than 8. And there's an and between those. So I know I'm looking for an overlap of the two answers. All right, I have negative 4x. I have 5x greater than 5 over 4 of the negative type. And, important to have the and, because it's going to tell me what to do in the end. 4x less than 11. X less than 11 over 4. So, x less than 11 over 4, here's 11 over 4. Open circle. Going this way. Here's negative 5 over 4. Open circle. Going this way. Where's the overlap? Between the two. So, negative 5 over 4 to 11 over 4, neither one's included. Last one, it's got a whole bunch of other stuff in the problem. I'm going to isolate the absolute value first. So bring the 4 over, get my 32, divide, (16). Now I'm going to look at this and pull it out, plus or minus x plus 12 greater than or equal to 16 in absolute value. So I'll say the positive x plus 12 greater than or equal to 16. This was a greater problem, so this is an OR. Negative x minus 12 greater than or equal to 16. I have x greater than or equal to 4 or negative x. Actually, let's do it this way. Let's go negative 28 greater than or equal to x. So now I have a negative 28, closed circle, going less than, a 4, closed circle, going greater than, but it's an OR problem, so when I state my answer, negative infinity to negative 28, this is included, this is not, or included 4, and infinity, closed circle. All right? So that's it as far as the absolute value goes. Now we're going to do some, hopefully these are kind of review problems from Algebra 1. I know we did them back then. These are work problems, which actually kind of work like a distance rate times time. Crane A can upload or unload a container in 10 hours, and Crane B can do it in 14. Crane A starts at 2 and B starts at, or Crane A starts at noon and B starts at 2, and then what time will they finish the job working together? So you'll notice we need to represent their work rate, how much of the work gets done in an hour. And you're going to assume they work at a linear rate or a constant rate. So if this is Crane A and this is Crane B, all right, and Crane A does the whole job in 10 hours working at a continuous rate, then he will do 1/10 of the job every hour. Likewise, this guy will do 1/14 of the job every hour. The amount of time worked, well, I don't know the exact amount of time they work because I don't know when they finish. But I know if Crane A starts at noon, he's going to work until he finishes, which is X. Crane B starts at 2, he's worked 2 hours less. All right? And if you take the work rate, multiply by the time worked, you get the total work done. All right? So this is X over 10, and this is X minus 2 over 14. Now, we want them to finish the job. Well, how much of a number or what number represents the total job? If these are fractions of the job, then the whole job must be 1, a whole unit. So we take Crane A's work done, add it to Crane B's work done, and get a total of 1. For problems like these, I would just take and basically clear the fractions. Okay, you could multiply by 140. I don't know if that's going to be the best idea, but you could. Okay, because I know that if I multiply 14 times 5, all right, I'm going to get 70. So if I take and say 70 here, then this guy goes to a 7x. This guy is going to go, like I said, to a 5. And this is 70. So this is 7x plus 5x minus 10 is equal to 70. I have 80 equals 12x. And then x is equal to 80 over 12. Like so. We can reduce that fraction. 80 over 12 is basically 20 over 3. Whoops. Or 6 2/3 hours. They want to know what time they'll finish at. All right. So basically, if this guy started at noon, all right, and its value is x, he finishes 6 2/3 hours later. So he'll finish at 6:40 p.m. All right. Next example, similar problem. One pump empties the pool in 7 hours less than another pump. They can do the whole job in 12 hours. How long is it going to take the larger pump to drain the pool? So we'll go small and large on these guys. All right, work rate, 1/7. Actually, it's 7 hours less. All right, so I don't know how long this guy takes a job to do the job. So let's call the large pump X, and we'll make that 1 over X of the job. And this guy will be 7 hours less than that, so 1 over 7 hours less. Now we do know that together they can do the whole job in 12 hours. So this guy works 12 hours, this guy works 12 hours, and then I multiply. So this is 12 over X minus 7, 12 over X, again, 12 over X minus 7, plus 12 over x is equal to 1. In this case, I'm multiplying by x times x minus 7. Notice we reduce, get 12x. This guy is 12 times x minus 7 is equal to x squared minus 7x. So I have 12x plus 12x minus 84 is equal to x squared minus 7x. I'm going to move this over to here. All right, I'll set aside equal to 0. So I have x squared, subtract 24 from negative 7, and I get negative 31x plus 84. This has got to be factored. So I've got x, minus 3 and x minus 28, I believe. I think that'll work. So I get 3 and 28 as my values for x, right? Going to be 28 hours, but because we can't go 7 hours less than 3. So this is garbage. Let's just reason it that way. All right, so our answer is actually going to be 28 hours to do it by himself. So in our last problem, it's going to be a little bit more difficult in that we're kind of at this point tied into doing the problem in one variable. If it were me, I would do this problem in 2 variables, but things like this are given to us early, so they're asking us to do it in 1. Let's take a look at the problem. The art class plans to take a trip which costs a total of $160. So I know that when I'm figuring out what it's going to cost, I take the people multiplied by the cash, and that equals 160 bucks. So why don't we do this? Let's call the people equal to x, and the cash is going to be the total cost divided by x. If I multiply these together, you can see that multiplying the people by the cash gets me 160, and I'm good. Okay, so this is going to be the premise we're working under. Then it says 2 members are going to be canceled. So I take the x and I subtract 2. Then the cost is going to increase. So here's the cost, 160 over x. It's going to increase by 4 bucks. But it's still going to cost 160 bucks total. All right, so now I've got my one variable equation. I can take and FOIL that all out. So I get 160 plus 4x minus 320 over x minus 8 is equal to 160. Notice here the 160s are going to go. I'm going to basically, I think I'll multiply x to both sides of the equation, getting 4x squared minus 320 minus 8x. Keep in mind this is now a 1, right? Because, or actually it's a 0, sorry, equals 0. And I'm going to put it in the right form, 4x squared minus 8x minus 320. I notice in this case that everything's divisible by 4, all right? So basically, I have x squared minus 2x. When I divide 320 by 4, I get a total of 80 equals 0, which works out really nice because x minus 10 and x plus 8 gives me that 80. Therefore, I can't have, well, I get values of 10 and negative 8, but if x represents the number of people, I can't have negative people. So I actually have 10 people to start with, and then 2 bail, so I really have 8 people going on the trip in the end. All right. That's all we've got for today. Another round tomorrow.